emergency. Hi, my name is Karma. Hello, my name is Natasha Anajaya. Hello, my name is Pudongli.
Distilled water, glucose solution, and DNS reagent are pipetted in duplicate into a 6 series of dry clean and label the test tube. After the above-mentioned solution are placed in the labeled tubes, the test tube are shaken well and then the test tube are placed in a boiling water bath for 5 to 7 minutes. The test tube are cooled. 1 ml of roset salt is added. Then, the solution is transferred into a cuvette. The extension of the color solution at 575 nanometer is read using test tube 1 as a blank. The readings are recorded and the relationship between the optical density and the concentration of glucose solution is plotted. Whether there is a linear relationship between the concentration of glucose solution and their corresponding optical densities is seen. This standard curve is kept to determining the glucose concentration in the selected sample that will be used for practical 2B. A direct and proportional relationship between glucose concentration and adsorbent at 575 nanometer was observed from the DNS assay data. Adsorbent measurements were taken in duplicate for each of the 6 test tubes containing glucose concentration ranging from 0.0 gram per liter to 1.0 gram per liter. It is evident from the results that adsorbent increased with rising glucose concentration. For instance, the average adsorbent at 0.2 gram per liter glucose was 0.1165 and at 1.0 gram per liter glucose, it reached 0.9950. At 0 gram per liter, there was no color formation, confirming that the DNS reagent does not react unless a reducing sugar is present. At 0.4 gram per liter, the average adsorbent recorded was 0.4590, while at 0.8 gram per liter, it increased to 0.8050. The observed data therefore support a clear line relationship between concentration and adsorbent. The plotted graph of adsorbent versus glucose concentration show an excellent fit to a linear model, described by the regression equation y equal to 0.95758 plus 0.0209, with an R value of 0.9986. This indicates that nearly all the variability in adsorbent is explained by the glucose concentration, confirming the sensitivity and precision of the DNS method across the 0.0 to 1.0 gram per liter range.
New learnings. Learn the principle of the DNS method, which detects reducing sugars through redox reaction under alkaline conditions. Gain hands-on experience in preparing a glucose standard curve and using a spectrophotometer for quantitative analysis. Learn the importance of precise pipetting and reagent handling, control heating for consistent color development, and using Rochellette salts to stabilize the color complex.
One of the challenges faced is difficulty maintaining a consistent heating across all test tubes, affecting reaction uniformity. Another challenge is risk of pipetting errors when measuring small volume, thus this can impact the accuracy. Last challenge, uneven mixing of reagent before heating that can possibly leading to inconsistent color development.
Suggestion for improvement. Use a temperature control water bath to ensure uniform and precise heating. Implement digital or automated pipettes to reduce human error during solution transfer. Use a vortex mixture to achieve complete and consistent mixing of solution before heating.